Welcome back. We will continue with tablet format apps. Tablet format apps have considerably more breathing room than handheld format apps as far as screen real estate is concerned. The iPad's 4:3 aspect ratio and large screen size ensures plenty of room for navigational and functional controls, but Windows and Android tablets also manage quiet service subtly with movie-like 16 to 9 aspect ratios. Stocks and index pins. Tablets format apps also rely on stack pattern, vertically stacking a primary area and one or more tabs, navigation, and action bars. These tablet apps actually are have vertical stack with a primary area and one or more tabs. Here you have two pins. The left is the index pin, while these are the main content pin. However, the extra real estate available on a tablet also allows the addition of one or more supporting pins. Should the app require it? Typically, the additional pin is an index pin. See Chapter 18, that list content items such as your email, inbox, or search result, the current selection of which is displayed in the detail in the main content pin. So if ever you need another pin, you can use this index pin for tablet apps. Another thing is that these items are controls that shows the current email set that you could use to later show in this main content area. We discussed this in the previous video. Now this is a good use of display real estate because it eliminates one level of drill down and allows users to quickly navigate and inspect a long list of content. These additional index pins can themselves have navigation and functions associated with them. So these are actually have controls and function or navigation functions. When you click that, it will that function will allow you to put that in main content, and in some cases when you right click, you're able to configure that specific email. These additional index pin can themselves have navigation and functions associated with them, which are housed in bars at the top or bottom of the pin. So the functions are usually in the bottom and then the top pin, such as here, edit. Frequently, the list of objects in the index pin can come from several sources, such as email. This requires either tab or drill down approaches to navigation. Search and filter widgets are also common controls in tablet index pins. So, search and filter widgets are also common controls in this. So you can search uh, and then filter this content area. iOS iPad Mail app presents a navigate index pin containing mail folders and their contents. In portrait mode, the pin is launched from a button on the left of the app's nav bar and overlaps the rest of the screen until it is dismissed. So it was launched from the button here. When you click, it will pop up. So this is a navigable index pane containing folders and their controls. So these are navigation controls that you can click to represent in this content area. In landscape mode, the pane is permanently placed adjacent to the detailed content pane. So actually what you call this is a detailed content pane. So there's two pane. Usually it's separated by splitters. When rotated to landscape, the standard patterns calls for the overlapping pane to become a permanent adjacent pane. So it will become a permanent pane. You can't, the characteristics of this again is you can't move this, just it has a minimum size that you can move. Pop-up controls. Tablet screens are large enough to support pop-up panels that don't overlay the entire screen, and that can replace navigation to a full screen control panel screen as is usually required in handheld format apps. So this it doesn't divide the screen. It's still full screen. It just pop up. So it's still a type of pane or panel. This pops up when used judiciously can improve task flow by retaining the context of the background screen and not feel as much to the user like going to a different room. So again, the concept of room which discussed in the previous video. The Procreate digital painting app on iOS makes extensive use of pop-up control panels as a means of configuring the drawing tools. In the app's toolbar, these pop-up panels show their connection to the tool via speech balloon-like carrot that emerge from the otherwise rectangular panel. So it's a control panel. It's like a model box or tool palette or pane as a means of configuring the drawing tools in the app's toolbar. These pop-up panels show their connection to the tool via a speech balloon-like carrot that emerges from the otherwise rectangular panel. So when you click this icon, it will show this orientation based layout. On tablet apps, rotating controls in place usually is an insufficient or undesirable approach. Instead, tabs, navigation, and toolbars need to reorient themselves on the screen in a sensible way by relocating to the top or sides of the screen as appropriate. So the tabs or navigation and toolbars need to reorient in tablets. So it's not the same as in mobile apps where you can only do one orientation. Overlapping panes that were available from a button need to be laid out adjacent to the main content pane. So here, but more complex apps are those dedicated to activities that have heavy bias toward one orientation, such as streaming, video app, landscape, e-reader, portrait, or any authoring tools that relies on a fixed layout of complex controls may select to support only one orientation. So some apps actually only support one orientation, especially those specialized apps. So any button that pops up like this needs to be adjacent to the main content pane so you can still see the context. Mobile versus desktop layout. However, due to the complexity of productivity and creative authoring apps that seek to replace similar desktop apps, there is more of a case for adopting more desktop-like toolbars and panes. So there is more complex app that mimics their desktop counterparts. But again, nothing can rival the complexity of the desktop app because they are just the right interface or tools for that kind of complex interaction. Audio and video production apps in particular seem well suited to a more desktop-like approach, as shown in figure 19.6. Here, relatively dense control layouts, multiple pins, complex toolbars and control panels, large pop-up panels or drawers, and drag and drop idioms make sense. So there's a dense control here, multiple panes, complex toolbar and palette and control panels which use to configure these settings of the function, large pop-up panels or drawers, and drag and drop. Later we will gonna see how drawers became prevalent on mobile application, and it's still true today. Figure 19.6, Steinberg's Cubasis and Corel's Pinnacle Studio are examples of media production apps that are well suited to a more complex layout that more closely resembles desktop apps. If your app is in this category, keep the following principles in mind. Make sure that the toolbar, control panel, and menu items have areas that register taps, known as hit areas. So the hit one that register taps, the menu, the control panel, the toolbar, are actually called hit area in the backend, and interim spacing properly scaled. Inter-item spacing are properly scaled for finger use. So make sure that it could be tapped by a finger, the size of a finger. Drag and drop is prone to accidental drops as a touch screen, so either avoid it or be forgiving of them. So we should avoid this drag and drop in this type of application. Pop-up panels, and we should strive to make one tap if we can for the function to make it as simple as possible. Pop-up panels should point to where they came from when possible and have clearly labeled headers. So these pop-up panels you should know where they pop ups like this. There's an arrow labeled clearly labeled headers for that for this like this wet round brush for that type of modal backs. Pay close attention to function hierarchy so as to keep workflow as linear as possible. Put the user on a single path to accomplish a task whenever possible. So if the user doing a task, make sure that you don't disrupt the flow. If you could make it in one path, the better. One click path, the better. Apps with complex layout should in most cases choose an orientation and stick to it rather than trying to support both portrait and landscape. Consider the alternative orientation an opportunity for a completely different display. So for complex apps, it's better to stick with the orientation. Hardware like control layout for certain apps, especially those in the domain of music production, interfaces that resemble hardware-based control surfaces appeal to users in that domain. While such interfaces can be quite awkward on the desktop due to the necessity of operating Fox hardware controls with a mouse or trackpad, The introduction of multi-touch input surface on the display changed this equation substantially. So some controls that or interface that resemble the hardware-based control appeal to certain domain, such as in music app. Designers should still take into account fingertip use for hit areas and spacing. They should allow horizontal or vertical drag gestures and be consistent about their use to operate rotary controls in addition to circular drag postures. So here you should allow for horizontal and vertical drag to provide more complex input. At the same time, make it consistent to operate rotary controls in addition to circular drag gestures. Also remember not to let your key interactions be artificially limited by hardware metaphors. A knob or slider. So here is a knob actually where you change the volume, like in volume control to operate a rotary. May not be. Also remember not to let your key interaction be artificially limited by hardware metaphors. A knob or slider may make sense for setting volume or mixing tracks, but using direct manipulation for activities such as shaping and scrubbing audio waveform can provide a whole new level of richness to creative process. So for manipulation, it's better to provide an option for dragging and then tapping to provide a more complete expression. Mini tablet format apps. So here is an example of instrument of Positive Grid's Final Touch app provides pro quality audio mastering on the iPad while making extensive use of hardware control metaphors. Its smart layout and workflow, along with judicious use of direct manipulation idioms in combination with the hardware like controls, make it both extremely powerful and easy to use. Navigation and layout strategies employed by handheld and tablet format apps will work for mini tablets with some caveats. Adjacent panes, generally not a good idea on full-size tablets in portrait orientation. Adjacent panes are usually far too cramped to consider on mini tablets. In landscape, at most 2 adjacent pins and perhaps a vertical tab bar can be supported. In portrait in particular, overlapping pop-up pins and drawers make more sense. So you should not provide adjacent pins for portrait for mini tablets. Only consider maximum of 2 pins when it's landscape. And then alternatively, you could provide overlapping pop-up pins and drawers. Drawers are discussed in the next section. Toolbars. In portrait view, these can feel distant from the action due to the tall, narrow form factor and increased screen size over handhelds. In landscape orientation, toolbars stuck with navigation bars leave little vertical space for content. So if it's landscape, the toolbars that stuck with navigation bar leave little room for content. Vertical toolbars may sometimes make more sense on mini tablets. So vertical toolbar makes more sense on mini tablets. Toolbars, I discuss in the next section. List, single column list tend to look out of proportion on mini tablets, even in portrait orientation, because it's just a single list. It's a thin compared to grid, swim lane, and card approaches tend to work better for the user's sense of flow in both orientations. So you should use grid, which divide faints, or swim lane, which we will gonna discard, or card, a combination of carousel, swim lane, and grid, and list. If your content is truly list-based, consider using vertical tabs or toolbars in portrait and adjacent index. So adjacent index or pane, so that you have two pane, so that it is more pleasing to the eye, and detail panes in landscape. So you have a detailed pane, like when you click the index pane or some controls, it will provide more detail. Each of these idiom is discussed in more detail in the next section. Pop-up versus full screen dialogues. Mini tablets are big enough that using phone-style full screen idioms for menu and dialogues won't work. So a full screen idioms for for menus and dialogues won't work here because of this because it's bigger than phone. This should be implemented as pop-up dialogues that overlap as on full-size tablets. Pop-up control panels for toolbars will also work. So pop-up control panels for toolbar will also work. It will pop up on the main content. This may take up the majority of the screen when open for that pop-up. So it actually, you can actually do that for a control panel pane or pop-up toolbar, as long as it will take up majority of the screen where when open, because it's bigger than phone. Mobile navigation, content and control idioms. Mobile applications share many controls with desktop and web applications, as discussed at length in chapter 21. So we discussed that in the previous video. However, due to the unique form factor and multi-touch input technology employed by the majority of modern mobile devices, they have evolved a unique set of idioms specially suited to mobile app use. So they share many of the controls in desktop and web application, but they have developed their custom idioms that fit on that application. Browse controls. Most mobile apps are optimized for browsing, whether it's music, videos, social networking updates, restaurant reviews, email, shopping, or search result. We do an awful lot of casual surveying in our mobile apps. Due to the limitations of the form factor and input options, it's much easier on mobile devices to browse and select content than to input data. So instead of inputting like a text, like we do in desktop, where we can enter a lot of text, such as in authoring tools, we actually use a browsing mechanism here, in which like we scroll list, we tap, we drag, etc. So we really or we avoid inputting large amount of text. So it's less action as possible to the user, but more function with that less action. Given this situation, it's unsurprising that mobile apps have developed a rich set of patterns around browsing through content. The first pattern is list. Lists are the most frequently used pattern for organizing content on handheld format touchscreen devices. So these patterns are the most common for organizing content, the main content pane on handheld format touchscreen device. These contents often include line items or blocks. So line items like list text in list controls, or list button or blocks of text. Controls such as checkbox or buttons is normal as well, and their labels and image or video thumbnails. So you may those are the missing part. We knew that this list could contain those type of controls, but for image and video thumbnails, that's new to us. Tapping a content item in a list typically drills down a level in the hierarchy, revealing either other controls or the content or the next level of grouping. Sometimes tapping a list item may also launch a modal pop-up or screen that provides a set of options for controlling the item, or it may navigate to a detailed view of the item itself that provides its properties or details that describe the item. List views often work in conjunction with tab bars. Uh, so Tab bars, we will discuss that later, to provide access to multiple screens of content. So for us to access multiple type of content on the screen or to search or browse it, list views or this list mechanism is often work in conjunction with tab bars. Each in its separately maintained list. So in each list that in conjunction with the tab, it is separate maintained list in the back end. Apple's Music app is a good example of this with list of albums, artists and songs available on different tabs. So here you have a different tabs for albums. So this is a tab bar, what you see. So it's an idiom. There's some more as well that when we click, we see now a list that could provide, when we click, provide us more details. Apple's Music app is a good example of this with list of albums, artists, and songs available on different tabs, each with own slightly different but related drill down hierarchies, as in figure 19.8. The iOS Music app has tab list of albums, artists, and songs, among others. Navigating between lists is accomplished via a bottom tab bar. List can either be finite in length or allow infinite scrolling. This kind of scrolling presents an initial subset of items from a very large set, such as web search results, and then presents an additional block of results each time the user reaches the bottom of the list. So this list could be finite or infinite, which we will discuss more in websites, web application, which is these are more prevalent. For example, for newsfeed content, where the most appealing is the new content, must apply infinite scrolling. So this kind of scrolling presents an initial subset of items from a very large set, such as web search results, and then presents an additional block of results each time the user reaches the bottom of the list. So those are for finite or infinite scrolling, such as viewing a large sets of data. So those are the common use for list or for browsing through list. Grids are used to organize content such as apps, thumbnails, function icons into regular rows and columns. So these are or used to organize controls basically. So those controls could have a selection control that provide complex functions such as an actual app, or a functions just a function, a thumbnail that contains another functions into a rows and columns. The most obvious example of this is the home screen of the iPhone with its editable grid of app icon. So when you hold this, you will be able to delete some of the app. iOS and Android home screens use similar app grid, both of which are derived from the original Palm Pilot. Microsoft, on the other hand, evolved its Zune interface into the Metro UI with its unique start screen grid that seamlessly and beautifully combine apps and notifications. Within an app, grid views, also called gallery views, often are used to present media objects. So there is another type of grid view, also called gallery view. Within an app, we could apply this UI that present media objects such as pictures and videos. This includes photos, videos, and music as well. Music albums with cover art or small encapsulated cards that could even provide more details of photos and videos in an infinite manner, containing image, text, and sometimes button or link elements to a web app or website. The iPhone's home screen uses horizontal swipe to navigate between grid pages. So to navigate here, the idiom is to do a swipe, horizontal swipe instead of vertical swipe. Most apps that use grids as a primary navigation and selection mechanism, such as RDIO, see figure 19.10, use pageless and sometimes infinite vertical scrolling to expose more grid objects. So since a grid objects could contain media, so this more provide richer browsing controls or mechanism or idiom that we usually use for these mobile apps, because again we have limited input that should provide a lot of function in a limited action. The direction of scrolling is nicely ambiguated by sizing the album art so that the bottom most visible row is partly cut off. This provides the necessary visual hint that a vertical swipe up will reveal more choices. So you can see that you could scroll down because of this because the bottom row has been cut off. So you have this control here to play. So there is a visual hint. So you can the RDO streaming music app using a two column scrolling grid. So there's two column grid. It's usual for phone, music phone, two column grid to display album of choices or media objects in a grid. The bottom most visible row is cut off. So the bottom of this media objects is cut off. Actually, it was programmed to cut off, which means that scrolling is vertical, not horizontal like in the apps. Apple Photos app shown in figure 19.11 uses a much tighter 4-column grid for the camera roll. So there is a 4-column grid, and in the bottom bar there is a three controls. So let's see. So there's a tab bar with this there's only tab bar in the photos up, which also scroll vertically. So again, this there's a top bar with two controls, select and then albums, and then this there's a bottom bar where you can choose in different grids. So instead of different lists, it's different grids, but it has the same format with the list earlier, right? It might be tempting to allow zoom in and zoom out on the grid via a pinch gesture, but generally this is not a good idea, especially in the narrow portrait orientation of the handheld form factor. Issues quickly arise concerning the legibility and hit area of the icons or thumbnails, as well as column width of text labels and metadata. So if it's a this you're working in a mobile app that has a narrow portrait orientation of handheld form factor, issues will quickly arise about the legibility of hit area of the icons or thumbnails, as well as column width of text labels and metadata. So how would you see the text describing those media when you allow the pinch in? So how would you implement that? That's why it's not recommended to do that, especially in this small uh, combination of column in a grid for mobile phone. As with list, tapping a content item in a grid typically drills down into a hierarchy, revealing either another controls grid or list of content items or media that has more content. But usually we limit that hierarchy because of the design principle of limitation and controls that is not being usually used. We want things to be discoverable for users, so we want to make it one hierarchy as possible. Or it launches a modal pop-up that provides a set of options for controlling the item. Or it could be a modal pop-up, like kind of like a dialog box that allow us to manipulate the attributes. So kind of like the selection control. Or it opens a detailed view of the item itself, as shown in figure 19.12. So here it provides a detailed view. Like list, grids can be either finite or infinitely scrolling, where rows or columns of additional items are added incrementally when the end of the grid is reached. So the same with list. When you scroll the rows or column, the items are added incrementally. So it was programmed in the added backend to be added incrementally when the end of the grid is reached. Grids also can scroll horizontally, just like list, as in Apple's Music app when the iPhone is rotated to landscape or orientation. So you should need to program the app as well to be able to scroll horizontally when the OS portrait change its orientation to landscape. So figure 19.12, when rotated to landscape view on an iPhone, Apple Music app display a horizontally scrolling grid of album art. Tapping the art drills down to a view of the album that includes the album art, vertically scrolling track list, and transport controls. So if we tap the art drills down to a view of the album that includes the album art, we can vertically scroll the track list when we click this picture, and then add transport controls that allow us to apply more function, kind of like imperative controls and selection controls inside it. Content carousel, so this is another type of browse controls that is a more innovative way to find things in less time. Screen carousels use a horizontal swipe gesture to navigate between similar full screen layouts containing different data or containing different content. So for screen, there's different type of carousel. For screen carousel, you use horizontal swipe gesture to navigate between different similar full screen layouts or content that contains different data. Content carousels, on the other hand, live within a single screen layout. So it has a different single screen layout rather. Sorry. For screen carousel, it has a full screen layout, meaning that it's on full screen. It could not provide modal way of looking or it could not divide the pane in two panes. It only has one panes. On the other hand, content carousels live within a single screen layout but use the same type of gesture to allow navigation between different content objects that are presented within that screen. Often they are media, thumbnails, or larger images. So for content carousels, it has a different it uses a media thumbnail or larger image to represent each content, but they can also be textual or cards containing both media and formatted text. So the cards, which I mentioned earlier, could also contain picture and video or text or links. So here the Crackle app on the iPhone left offers a good example of a content carousel on its feature tab. So these are content carousel. It's in a single screen, and then you are allowed to scroll this horizontally or swipe horizontally rather, and then you're allowed to navigate between different content objects in that screen. It works well, but the arrow that indicates a drill down to the details of each carousel item is sized and positioned such that it looks more like a way to navigate to the next carousel item. So you may think that when you click this, you will go to the next carousel, but it's actually providing more details, which is bad design. Safari on the iPhone, right, offers an example of a vertical carousel. So these are the type of vertical carousel in the place of browser tabs. So the iPad App Store App Center makes use of a 3D layer effect. So here it use a 3D layer effect type of carousel. So here it's vertical carousel, it's not horizontal. You can swipe left or right to remove the tab for the browser. Now content carousels present a row of content items carefully sized and spaced so that they bleed off the edge of the screen. So here this is a content carousel, is a horizontal row of content. It will present a row of content that could be scrolled horizontally that are designed to bleed off of the screen. So it's like over the screen, or they fill the screen from the left to the right edge and use either arrows near the left and right screen edges. So sometimes they use an arrows, or oftentimes you use arrow here on the right edge or left, but it's usually on the edge. Screen edges or page marker widget. Some carousel, such as the one at the top of the iPad App Store app, makes you make use of 3D layering effect that puts the focus item in the carousel in front of others. So here the 3D layering effect purpose is to put the highlighted or the selected carousel in front of others. Properly designed carousel should wrap circularly from end to beginning rather than making the user swipe all the way back to the start. They also make it visually clear when the last item in the carousel has been reached. Typically, content carousels are used to present a relatively small set of objects that the app is meant to feature or highlight. So this type of presentation, aside from list and grids, are actually used to highlight the small or more important, like the newest movie or TV. As such, only one carousel should be employed on a screen.
So only one, and it should take the most prominent position in the layout, such as this and this, for the iPad and the movie app. The app has a large carousel at the top of its feature tab.
It wraps and includes a page marker widget so that the user knows when they return to the beginning. So this widget or this small, let's see, yeah, this small is actually a widget, and it drops the content carousel. Uh, it has a large carousel at the top of its feature tab. It wraps and includes page marker widget so that the users know when they return to the beginning. This trick works only with carousel containing short list of items, because when you have a large, you will have a large wrapper of widget, and it wouldn't work. It also auto advances the carousel every few seconds, so it was also designed to auto advance every few seconds. So that's a known idiom. This help users understand behavior, as well as helping the app feel more dynamic, and ensuring that users are exposed to the featured items. So this is what makes the app actually feels like magic and dynamic. Care must be taken not to auto advance a carousel so fast that users have trouble reading or focusing on the content. This animation should also pause while the user is interacting with other elements on the screen to avoid disorienting transitions. So when your user are tapping on one of the content, it should be programmed to pause the auto advance. Much less common is a vertically oriented carousel. So most common is horizontally oriented, but less common is a vertically oriented carousel. Apple employs one in Safari for iPhone iOS 7 in place of browser tabs. The user swipe up and down to browse, taps to select, and swipes left to delete a tab. So like this, when you scroll left, it will be deleted. Swipe up and down to choose a tab, and then tap to select. Swim lanes. So this is a more sophisticated browser controls. Swim lanes combine the carousel natural browsability with the data density that only a grid can permit. So it provide more data, unlike the carousel that only feature the most common, like 1 to 3 or 1 to 7 newest content. Swim lanes jump pack those like this. Also, these are actually just controls, guys, like what I've said in the previous video. So each type of browser controls. Simply put, swim lanes are vertical stack of carousels. So it's a combination of carousels instead of just one carousels, each of which can be scrolled horizontally, independent of the other. So again, it's scrolled horizontally instead of vertically, as those in seen in browsers. Swim lanes thus are a clever way to allow the user to browse multiple categories of content with minimal navigation. Swipe through one category and the next is waiting pristinely below it. This is a big advantage over using a fixed grid that moves columns of content objects all at once. So if you use a grid that moves the column of content object all at once, like this that we have seen, we have a limited interaction capabilities or input or function, because it move all the content all at once, right? When you swipe it down, 2 columns are being moved, or these 4 columns are being moved.
While here you can independently move this each carousel independent of each other. Swim lanes thus are a clever way to allow the user to browse multiple categories of content with minimal navigation. Swipe through category and the next is waiting pristinely. This is a big advantage compared to fixed grid move columns and list as well, which is more for just single pane on the screen. So here, the Netflix app uses swim lanes as its primary browse paradigm. Apple's App Store combines the use of a carousel and a set of swim lane for item highlighted on its featured. So you can combine this a carousel and swim lane depending on your circumstances. But Netflix use this swim lane alone for primary content for their movies. The Netflix app makes great use of swim lanes for category-based content. User scrolls vertically through the categories and horizontally to browse a category. Now you can browse vertically, but you're browsing different categories of the carousel. It works well even though the screen portrait orientations makes for a narrow viewport on the content. So even it's a portrait, you still maximizing the browser option or browse controls. The Apple App Store uses both a carousel. Sorry, we are repeating ourselves. So the authors have seldom seen swim lanes that auto-wrap back to the beginning of the list, but they probably should, with a marker of some kind between the end and beginning object, so that users receive visual feedback that indicates when they have returned to the starting point in the list. So you can actually wrap this in a widget, this object in a widget that tracks because it's not an infinite scroll, that wraps back to the beginning of the carousel. So while swim lanes typically are used for finite list of featured items, you can imagine them being used with infinitely scrolling list as well. You can also use this in like a news tab. Imagine categorized search results, for example. However, swim lanes, unlike carousel, should never auto-advance. So it should never auto-advance because of user issues. Cards is another type of browser controls the way we navigate our apps. Cards are relatively new idiom for mobile that perhaps in some way trace their roots to their original HyperCard on the Mac. Back then, Macs had low resolution, much lower than current mobile devices. Therefore, it seemed to make sense to be able to combine text and visual media into nicely formatted chunks of information suited to the display's limitation. So because Mac has low resolution back then than current mobile devices, it makes sense for them to combine text and visual media. So this where the card invasion of card came from. HyperCard was meant to be an authoring environment for the masses, but it ended up being a way for developers to easily create rich media, content-centric interactions. Rich media which could contain links, videos, pictures, text, you name it. So those are rich media and content-centric interactions. So again, content, you're manipulating objects. So fast forward to modern mobile applications and the same need arises. How do you present meaningful chunks of rich media content for easy consumption on a constrained display? So that's a design problem. Add to this the social and contextual nature of most mobile interactions. So because the purpose of this mobile interaction is for transient, right? It's just context basis. So you're looking really for content based rich interfaces. And you have what exemplifies, because you sometimes use it for video, right? You sometimes use it for picture, you sometimes use it for social media, for text, etc. Um, Therefore, it seemed to make sense to be able to combine text. Sorry. Add to this the social and contextual nature of most mobile interactions, and you have what exemplifies the modern card-based UI, a self-contained interactive object combining media, text, web links, and social actions such as commenting, sharing, tagging, and adding media. So this social action or functions is actually text-based in the back end, but it has been visualized. So that's the commenting. It's just a controls or selection control in the back end, sharing, but it is visualized as a card. Now this card is actually self-contained, so it means that it has separate cards in the list. Now, as we will see, this type of presentation is more dynamic, that allows us to do more with less screen. So the Google Search app, Google Now feature, has a different approach to cards. It is more focused on the contextual information, time, location, and information pulled from the usage of other apps than it is on social interaction. So the Google Search app is more pull their information, or the objects or selection and imperative controls on the other app on their database. So the Google Search app uses cards that return encapsulated snippets of useful information based on the user's current context, including location, time, and relevant related information pulled from other Google services. So since you're using this phone, this smartphone, for different contexts, therefore you can combine different contexts in different cards. So this is actually how our phone works. So here, Facebook and LinkedIn apps both use cards as a central idiom. So these are actually the idiom that we've learned to use. So each card has like, comments, share, and then this you have a top bar that allows you to search, and you have a controls here to see pop-up window, and you have 1 2 3 4 5 bars and more, because those are learn idioms that we combine now with card. And you have infinite scrolling, and then the card has been cut as well, just like with the carousel, or grid, that intelligently disambiguate the nature of scrolling, so that become an idiom as well. Google cards are small encapsulations of data pulled from other Google services such as weather, maps, stocks, restaurant reviews, and notifications pulled from calendars and email data. So this is actually how Google started. So they have these different apps such as map, weather, restaurant reviews, stocks, notification pulled from it, and then combine it in one app. So tapping their content takes the user to the full app or web interface from which they originated. So it's actually web interface or website that where the interface originated. Google's cards also have individual settings that can be accessed via modal box, tapping an icon in the upper right corner. Doing so flips over the card, revealing access to a configuration interface. It's not a modal box, it's like a flip, which is amazing. The Google Search app uses cards that return encapsulated snippets of useful information based on the user's context, including location, time and relevant related information pulled from Google service. Cards are most often displayed in a scrolling vertical list. So instead of horizontal as carousel does, or and the grid icon for mobile apps, it displayed it in a scrolling vertical list like in Facebook, but they also lend themselves to grid, carousels, and swim lane layout. So we can provide a carousel or a swim lane layout to provide here a different two swim lane with two carousels, and then we can also provide a grid layout just like in Facebook. It cut that column. Facebook Paper App provides a good example of the use of cards in a non-standard layout. So it's not a standard layout. The top half of the screen is a category card that cycles through individual posts. If it is topped, the post is expanded on a full screen card as shown in figure 19.17. So here when you tap this card, it will expand on a full screen. So kind of like the nature of mobile app or in the grid part. So the Facebook page app is a good example of cards used in a non-list layout. So it's not a list for Facebook. So as you can see, we've transformed from list to now cards, and we now Facebook didn't use list layout here. Content navigation in the app is achieved via a card carousel of content categories, each of which automatically cycles through recent content. So it's like a carousel, two carousel. So it's this swim lane, and then it automatically advances, and an infinite card swim lane that the user can browse through. So here it's a the other is an infinite card swim lane. Actually, it's actually a swim lane, and then here is a carousel that advance. So they combine it. However, the difference with the Netflix swim lane here is that you scroll or you swipe the Netflix swim lane vertically, where here you swipe it horizontally. Under the category card is an infinitely scrolling swim lane of posts fitting the category. So here all the related category. Swiping up on this expands the swim lane to full screen height, making more detailed content visible. So when you swipe up on this content will be in full screen height, because like emphasizing this swim lane, and then it provide more detailed content visible for that specific category. Swiping down returns them to the bottom of the screen. So if you swipe this down, this carousel will go back. Tapping any shared content inside the expanded card takes the user to the content's original source. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you tap here at the top, you will go on this post or on that card. So that's how we browse the complex controls on mobile app. So that's the idiom that we developed there. Navigation and toolbars. Bars are the primary mechanism for navigating to different functional and content areas of handheld mobile apps. So there's actually a functional and content area. So those two are usually divided. and bars are the primary navigating mechanism for that. So this is our actually another type of browse controls, or a way for us to navigate it. So here, this browse controls is actually more of, sorry, it's a browse controls. The list and up to cards is a browse control, and this navigation and toolbars are actually for us to navigate functional and content areas. So we're navigating an area, functional and content area, while on the other browse control, we're navigating medias. Like list and grids, they date back to the earliest days of mobile touchscreens. Bars are narrow, horizontal regions at the top or bottom of the screen that consists of tabs like tab-like or button-like controls with either icons or text labeled, and sometimes both, as in many iOS apps. So it's actually a narrow horizontal regions. So it's you can think of this as areas where you put the functional, the imperative and selection controls. So it's an area that allows you to manipulate the content via function imperative or selection control. So bars are narrowed horizontal regions at the top or bottom of the screen of these tablet apps that consists of tab-like or button-like controls with either icons or text labels, sometimes both, as in many iOS apps. The affordance of these controls used to be more prominent. However, probably to their detriment, the major mobile operating systems have gravitated toward a flat visual style. Although this significantly reduces visual clutter, it also has the unfortunate side effects of requiring more cognitive work for users to identify active controls. So the flat type has been an idiom, but an active controls actually help us to see what is the available control. So at this point, most users have been trained to assume that any text or icon living within a bar is a navigational control of some kind. So it's like a browser control of some kinds that we could click. Sorry, not navigational control. It's like a type of control that could help us achieve our goals or type of functions. Tab bars contain a set of text and or icon buttons. Tapping a tab button switches to a different list or grid view in the main content area. So if you tap a button or control inside this tab bar that contain a set of text and icon, it will switch you to a different list or grid view of the main content area. So it could send you to a different cards or list or grid view that would allow you to search more and view more rich data. As you'd expect, these are for views, right? Instead of a page-based, which a website actually does. So it's a different navigation in web application. Each tab in a tab bar maintain its own content hierarchy of associated lists and grids. So there is an organization of this list and grid on that on each control on the tab bar. So each tab in the tab bar. So the control in the tab bar is actually called a tab. So that each tab on the tab, still a control, but it's tab since it's tab bar. Associated list and grids and typically preserves the state of that hierarchy while the app is running. So it preserves the state unless you close the app. Tab bars frequently found at the bottom of iOS screens and more frequently at or near the top of Android and Windows Phone screens as shown in figure 19.18. So here, as you can see, use of tab bars in iOS, Android, and Windows Phone. iOS tab bars typically are at the bottom of the screen, and Android tab bars generally form a secondary navigation beneath a nav bar. So here you can see you have two bars. The tab bar for Android are just a secondary navigation tool. As you can see, you have a navigation bar, top navigation bar, or action bar in Android terms. It's actually called action bar, the top of the tab bar. Windows Phone uses a tab bar that is purely textual without rendering a bar rectangle. So there's no rectangles. You can see wall, photos. So some tablets, vertical tab bars align to the left edge of the screen. So the tablets are this tab bar for tablets are aligned in the left instead of the bottom or top. Spotify and Twitter currently use this tab bar in their iOS tablet apps to switch to different tabs that has different lists and grids. So Twitter and Spotify use vertical tab bars in their tablet apps. They use buttons containing both icons and text for clarity, which works well given the large amount of vertical space available. So it works because it has a large space. More controls. The narrow aspects ratio of most handheld screen, as well as the need to provide fingertip size heat areas, limits the practical number of controls that can live in a bar. So the number aspect ratio of the handheld and the need to provide a fingertip, which is a larger area, limit the number of controls available compared to desktops that live in these bars. So both iOS and Android deal with this limitation using two strategies. So here, more controls in iOS: music up, left, and RDO right. So there's this more controls or more tab. The more tab, it will provide you the list of more controls, list or grid of more controls list of or grid of more tabs that it could not fit in bottom or top part. So here, the more control shown in figure 19.20 is a tab bar or action bar control that gets around the limited screen real estate of mobile apps. So tab bar or action bar control. So sometimes it is called action bar as well. This tab bar that gets around the limited screen real estate of mobile apps. In iOS, actually the action bar is not actually the navigation bar. It's the action bar is synonymous to tab bar, but it gets around the limited screen real estate of mobile apps. In iOS, this is usually a tab that shows a screen of additional navigation options. It often has an edit mode that allows the user to change tab, to drag an option from the screen onto the bar, which swaps the drag option or drag tab with the one occupying the slot in the bar the new option was dropped on. In Android, a more control lives on the right side of the action menu. So here, the action menu or action bar in Android, the more is in the right side and opens a pop-up menu of additional navigation options. So here, they actually use a pop-up menu or more typically functions or more tabs that allows you to do more. Some iOS apps such as the RDIO streaming music app for iPhone uses a similar idiom in the upper right of the screen as a way to select additional option via full screen model pop-up. Sorry, this Android, it's just a model pop-up, but it's not a full screen. But for some apps, like this RDO for iPhone, actually occupy full screen. So it's still in the upper right screen as a way to select. So it's the same with upper right. So some apps actually use this type of Android idiom in iOS. Carousels. So here, we will put the carousels that we put in swim lanes into now tab carousel. So here you have 3 tabs. A different approach to the same problem with that the more control addresses is the tab carousel, which elegantly marries the concept of tabs with that of horizontally swipeable carousels. So this tab carousel actually solved the same problem that more tab addresses, which elegantly mirrors the concept of tabs with that of horizontally swipeable carousel. So instead of like the swim lane of Netflix that is vertically swipeable, here is actually horizontally swipeable. Now tabs are shown in the tab bar. So this still shown in the tab bar, but within the tab bar you have different carousel that could be horizontally swipeable. Tab bars are shown in the tab bar as usual, but extend off the edges of the screen. So it still show in the sorry, this actually could be swiped. This tab bar, playlist, song, albums, you can swipe that to the left to show more tabs. The selected tab is centered or otherwise highlighted in the tab bar. So it is centered. The selected tab will show more options or controls or tabs, collection of tabs. Or it's highlighted. I mean, it's centered, but it's also highlighted to provide a progress view. Tapping another tab selects it. Swiping the tab bar, and in some cases, the view it controls. So sometimes this view or content that this tab bar controls selects the adjacent tab on the left or right. The adjacent tabs such as songs and albums, and slides the content into view as shown in figure 19.21. Spotify's iPhone app uses a tab carousel in its Your Music section, which is accessed via its main navigation drawer. So this tab bar or tab carousel rather is in your music section of, or which is the main navigation drawer. So drawer, we will discuss that later. That's a pop-up that allows us to control more functions. such as this tab carousels. So as with other carousels views, it's important that at least one tab label is initially shown extending off the edge of the screen. So to provide hint of scrollability in the tab bar. So it copies the grid which it cut it so that it disambiguates the scrollability of this view. Windows Phone uses a variant of the tab carousel as a primary navigation mechanism in its apps. So the Windows uses a variant of this tab carousel, which is it is main navigation. The tab bar is not rendered, but purely textual tabs are employed, like what we've seen earlier. Nav bars and action bars, so we're gonna discuss this, which we've seen in Android earlier. Nav bars located at the top of the screen provide a way to navigate a list or grid hierarchy, as shown in figure 19.22. So navbar, which we've seen in Facebook for Android earlier, at the top of is actually at the top of the screen, and it's a way to navigate a list or grid hierarchy. Again, that's hierarchy because it is organized in such a way that its most important is at the top. Typically, they contain at the very least a back button on the left and the title of the current list. So at the very least, like this visual design, you have a navigation bar that allows you to go back, grid or other type of current. There's a title of the current list or grid or other type of content screen in the center. So at the center of this navigation bar, there is a title of the list or the grid or the content that it views. Android call this set of controls an action bar. For Android, so actually the navigation bar and action bar is the same, but it's still a kind of like type of tab bar. So it's more complicated type of tab bar. Frequently, function menus or buttons are included on the right. So usually there's a function buttons or menus. So those menus provide more functions on the right. So like here, you have more and share. So here, use of navbars in iOS left, Android center, and Windows Phone right. Android encourages an action bar at the top of the screen, which incorporates navigation and access to functions. Android and Windows Phone also makes use of a system level nav bar. So these are actually a system level nav bar that we see on the every app on our Android that allows us to go back to the screen. So it's the bottom of the screen. So the reason why they recommended it on the top, the app level navigation bar at the top, is because the system level nav bar is at the bottom. Windows Phone Metro design language discourages use of tough nav bar. However, for Windows, it discouraged the use of top nav bar, but it also uses system level navigation bar. Most version of Android and Windows as of 8.1 have a system level navigation bar at the bottom. It contains a back control which takes the user to the previously viewed screen regardless of up or hierarchy. So regardless of app you open, the operating control it, so you go back to the previously viewed screen. So it's not actually home, but the previously viewed. So a home control, it's where it takes you to the home screen, and recent control. Windows Phone also includes search control. This the presence of ubiquitous bar at the bottom means that Android apps typically place most of their app navigation uh, at the top of the screen. So this app navigation is at the top for Android apps. Toolbars and plays. Toolbars contain buttons that execute functions on the current or selected app content. Windows Phone permits 4 action buttons in its action bar, called an app bar. Toolbars contain buttons that execute functions on the current or selected app content or view. So, Windows Phone actually permits 4 action buttons in its action bar, called an app bar, which typically is placed at the bottom of the screen. So Windows Phone permit 4 action buttons such as the search button, the back and the home control, etc. iOS apps, there's actually a window icon here, kind of like in the desktop idiom. iOS apps often place an action button or two on the right side of their nav bar. So actually, the action button is what we were gonna discuss here for Windows Phone. There's 4 action button at the bottom, while on iOS often has two on the right side, 2 action button on the right side of their navigation bar. But apps designed to let you author or edit media rather than simply viewing or sharing it often replace the standard bottom of screen tab bar with the toolbar. So sometimes this are replaced, the one that we see earlier, with a toolbar such as this that allows you to change the resolution and contrast of the brightness. Google encourages the use of its top screen action bar. So since the system navigation bar is at the bottom, they encourage the use of action bar of 2 action bar for iPhone and 4 action bar for Windows at the top, which combines back navigation with action buttons. So the app could also use system level for their app action buttons at the top. It is recommended adding a tab bar under this if the user needs to navigate multiple views on the app. Google's action bar even supports view switching via a drop down on the action bar itself if the stock action and tab bars take up too much space. So it allows the switching on the action bar bottom using a drop down at the top of the screen, kind of like become a modal that allows you to switch on different action bar. Most audio playback apps place a transport bar or control pane containing playback related controls at the bottom of their now playing screen. So there's actually a transport bar or control pane containing playback related controls at the bottom of their now playing screen. So for music app, they use a bar for that has a transport bar like YouTube that allows you to play and pause the video at the bottom of their now playing view. Toolpali, a variant of toolbar, similar to their desktop brethren, use iconic buttons as a way to access tools that operate on a document. Drawing and painting tools are the most obvious example. Toolpali on tablets apps makes heavy use of pop-up control panel to allow the selection and configuration of tools. So this toolbar, which is a variation of toolbar really, that we saw on the desktop, makes use of a pop-up control panel of or pop-up control pane that control the selection and configuration of the of their tools. So this tool palette actually allows you to select the object, and also it allows you to configure the functions that you will apply to the object. So that allows to for more complicated actions. Vertical toolbar and palette. Now we can use the tool palette as a vertical. On tablets, more complex toolbars supporting pop-up control panels and palette are used at both the top and bottom of the screen. So since it's more complex, you have a toolbar at the top and then at the bottom. So this toolbar acts like a menu or dialog pop-up control panel that show more controls. Vertical toolbars run along the left or right edge. So there's also a vertical toolbar on left or right edge as well if it's more complicated. And sometimes both. ArtStudio shown in figure 19.23 is a good example of an app that makes heavy use of rich complex toolbars. So the ArtStudio uses vertical toolbars as well as a desktop like menu bar and sliders embedded in its bottom toolbar. Authoring tools like this begin to rival the complexity of desktop applications. The tablet screen becomes quite cluttered with these many controls, so ArtStudio lets you hide them while working, similar to desktop design tools such as Adobe Shop. It also uses sliders icon embedded in its bottom, so it's embedded. You cannot really hide it. So it's still a toolbar that allows you to change the contrast of the image you're editing. Tool carousels. So if there's a tool palette and toolbars at the four edges of the screen, we also have tool carousels, which mimics the carousel part of the list and grids. So just as carousel have crossbed bread with tab bars, they have also combined with toolbars that allow functions to be accessible with horizontal swipe. So anything that could allows the function for horizontal swipe carousel could also be applied on this tool carousel. So again, we have carousel, swim lane, tab carousel, and tool carousel that allows us to swipe this different organization of controls. Each item in the tool carousel is labeled thumbnail that both describe and shows a small example of the filter or effect applied to an image. So each item in this tool carousel, like this, when you swipe this, you have this different type of filter, and then you will immediately show what will the picture look like when you apply that control. So here, Google Snap Speed Up uses a carousel to let you select the tool. After it is selected, the appropriate controls for the tool are shown. In some cases, including a secondary tool carousel for choosing a specific setting. So here it's a carousel as well that allows you to choose setting that could be related on the other tool carousel. So by stacking two bars, you can build a rather complex set of features in a way that tames the complexity. So it simplifies the complexity of the function using the stock toolbar because it's just in one screen. A toolbar lets you select the category of tool, effects, filter, adjustments, and a tool carousel contains items for each specific tool or variant in a category. So a toolbar lets you select the category of tool, like effects, feelers, and adjustment is still a tool carousel. And a tool carousel containing items for each specific tool that could be chosen on that toolbar or variant in that category. Menu bar, an idiom to avoid in mobile. Apps like Art Studio and Cubasis for iOS use complex desktop like control layout. So it's an idiom that you need to avoid like this. Art Studio take this a step too far by implementing a desktop like menu bar. The Art Studio app uses vertical toolbars as well as a desktop like menu. Here, a vertical toolbar. Steinberg's Cubasis and Corel's Pinnacle Studio are examples of media that applies that. This isn't a good idea because a row of text labels in a bar, such as this, provide become unreadable, especially for intermediate users. Typically means a tab bar and a desktop style menu bar interaction is unexpected on a tablet. So you may think you could do like a right click here, but you can't because it's a mobile interface. Second, most of the functionality remains hidden in the menus, which allows require you to do a two-level hierarchy, which hide the screen and provides more cognitive load, especially for intermediate users. When it is exposed, it still isn't clear from the menu label what the functions will do. So using that label, you don't know what it will do, so it's not intuitive. An approach that uses both a toolbar and a tool carousel, as described in the preceding section, can accomplish most of what a menu bar can do. So like in the image editing app that change the filter, those are the things that you need for that, but in a less visually dense and more visually explanatory way. Drawers, so these are I was talking in the previous video, these are the most useful because it combines all these advantages in one amazing idiom that is perfect for the interface. Drawers are a clever idiom that provides access to a vertical list of navigational elements similar to tabs. So these are actually from a list type. So it's not a card type, etc. But it's a list. But it mimics the tab bar that provides more tab or controls. So you can put the card inside this. So they use minimal screen real estate by hiding in a panel that lives in a layer under the main content area. So it's actually a layer under the main content area. So that's how it pops up like a drawer. The drawer icon is also called the hamburger icon due to its shape. Three short stacked lines. So stack related to what is the list and grid are also applied in this hamburger drawers. Tapping this icon or sometimes swiping across the main content area slides the content area horizontally to reveal the drawer under it. So it actually slides the main content area when you tap that or when you swipe across the main content area. So that's the idiom that we've learned to use. So as with tabs, the current selection is highlighted, same as the tab bar. Tapping a drawer item simultaneously swap what is displayed in the content area and snap the drawer back shut. So it's two function at once, like a selection control. But it's also kind of like an index pane as well that allows you to select what will be shown in the main content area. Items in the drawer are usually textual, but they have icons and other adornments. So it is usually textual to provide more meaning, but it also have icon just like in Windows File Explorer. So this is the Gmail app on the iPhone. Uses a drawer with additional navigation elements inside it. Uh, it's a little disconcerting that the account management UI slide down from the top. So here, the account management, when you click, it slides down from the top, while the settings UI slide up from the bottom. So here, if you click the settings, there's a dialog model box that will pop up from the bottom, which and takes up the full screen. And then these settings will take up the full screen. So the idiom is contradictory, even though both controls are next to each other in the drawers. And since they are similar, they should pop up downwards. Secondary action drawers. Drawers can be used to replace a navigational tab bar. So the navigational tab bar or action bars that we use to go back to or provide controls or functions at the right side could also be used as a secondary action drawer, or can be used to interact with the secondary set of objects in the app. So those are the secondary objects in the drawer. Drawer usually slide open from the left, but not always. Some secondary actions are put in a drawer that deploys from the right. So these are the objects on the app that replace the navigation bar at the top of the Android app. So sometimes you cannot go back here on the app in replacement for the navigation bar, but you have a secondary drawer for the secondary objects, such as this current online friends. So the current version of the Facebook app for the iPhone uses a set of fairly standard bottom tabs. So there's a bottom tabs, a standard, including a more tab for its main navigation. It also offers a right hand drawer that gives you access to a list of online friends for chatting, as shown in figure 19.26. So this is a secondary drawer. For for its main navigation, it used the bottom bar, but for navigation bar, it replaces the right controls with a right hand drawer. Double drawers. Path, an intriguing timeline-based social networking app on iOS, has opted to minimize its use of tab and toolbars. So instead of tab and toolbars, replacing the menu type of dialog model of that Art Studio earlier, it actually used the secondary double drawers. The path design, as shown in figure 19.21, uses two drawers, a standard left-hand drawer for primary navigation between views. So actually the left-hand drawer is usually the navigation between views on the app. So instead of the navigation bar or toolbar, it still has a navigation bar, but this drawer is the primary switcher for different views. And a Facebook-like right-hand drawer for messaging friends, such as the online friends that we saw earlier. Path also use a non-standard but interesting tool menu control. So again, tool menu control, TMC. It's still a control, but it's a tool control that fans open from the lower left corner of the main content area when activated. So here on the lower left, you have a tool menu. Although it adds a tab to access these functions, the interaction is both clear and pleasing in its execution, because it pops up this new window with an angle to the left shape. So here the Path app on iPhone uses both a standard left-hand drawer for primary navigation and a right-hand drawer for messaging friends. In addition, Path uses a non-standard pop-up action menu. you can think of that as a pop-up action bar that fans out from the lower left corner of the main content area when tapped. Item level drawers. Some handheld format apps have taken the concept of a slide to reveal drawer and applied it to individual items in a list. So again, we went back to the list, but we applied the drawer on that individual list, and then it's a slide to reveal concept of drawer. It's like a you call this uh, slow but slow way of providing a increase menu option. So yeah, but then it needs to be added to all items, wasting horizontal space. Sorry. Sliding an item to the left or right, depending on the tab on the app, reveals a toolbar under the item. So when you select an item to the left or right, depending on the app, reveals a toolbar. It will reveal a different type of toolbar under the item, which avoids the need for a toolbar at the top or bottom of the content area. So you don't need the toolbar or navigation and um, navigation bar at the top or bottom, and a toolbar for main content area or a drawer for main content area, because when you slide an item to the left or right, depending on the app, it will reveal a toolbar itself under the item. Although this approach may seem clever, it actually has a number of drawbacks. It is difficult for users to discover unless some sort of visual cue is added to the list item, because list or the controls inside these drawers, tab bars, menus needs to be uh, uh, provide a rich visual modeless feedback that allows the user to see that it's an active controls. But it then needs to be added to all items, wasting horizontal space. So this rich visual cue needs to be added on the items, which already a text base, which waste the horizontal space. Desktop applications have the benefit of the hover state to reveal such controls without cluttering the interface, but mobile apps do not. The swipe items can be obscured when the drawer is open. So the swipe item that came from it became like a tree hierarchy. When you click that item and slide that, it will obscure those next list or currently viewed um, tab bar will obscure the previous one. So the user would need to remember what it is, adding to mnemonic memory work. The per item swipe gesture means that other more standard horizontal gestures, such as those for deleting an item or opening a global navigation drawer, may become either confusing or impossible. So horizontal gestures here, such as for deleting the items in the list, becomes confusing because you don't know if you're deleting something or swiping on that item for a new navigation bar, or opening a global navigation bar, such as we saw in the drawer, or navigation of the drawer, may become either confusing or impossible. The Slacker Music app on iPhone, shown in figure 19.28, provides a workable example of item level drawers for both list and grid items. So again, we went back to drawer and list. Swiping to the left on the grid items for our artist stations or albums, and swiping list items for tracks reveals a drawer containing an info button, and tapping it takes the user to detailed metadata. So when you swipe left on this grid items for artists, it allows you to see uh, it will reveal a drawer containing an info button like this. When you swipe that, sweet dreams are made of, and then it will allow you to see details that allows you to check its metadata. So while this reduces UI clutter, its discoverability is low. Because swiping individual grid item is a non-standard interaction. Therefore, this type of interaction requires some explanation in a welcome or help UI. Even then, it's questionable whether most users will find it. So here, Stalker's naming musing up uses item level drawers in both grid and list views to give access to an info button that takes the user to a detailed metadata screen for the selected item. Although it is elegant in terms of avoiding clutter, its discoverability is low. So you need to balance the clutter and then discoverability. Drawer behavior to avoid. So the Gmail app drawer implementation shown in figure 19.21 that presents the drop down for account UI and settings from bottom to up also present an object lesson on the need to carefully consider the overloading of animated transition for accessing options. The Gmail app main drawer opens as expected with the content pane sliding off to the right when the drawer icon is tapped, or when the content pane is swiped to the right. Within it, the navigation null choices, email folders, scroll up and down as expected. So here, when you navigate this, you scroll up and down and you're gonna be able to navigate. That's good. From there, things gets complicated. The account management UI is a toggle control in the action bar at the top. So it's a toggle control. It's actually a toggle which we discussed in the previous video. It's a toggle type of control at the action bar at the top. So this is actually an action bar, kind of like a navigation bar. Here, when you click this, you go back to the main content. Activating it slides down a pane that covers the drawer's contents until either an account is chosen or the pane is dismissed. So it blur the main content, the drawer's content here when you slide it down until either an account is chosen or the pane is dismissed, or this entire pane is dismissed. And the next to the account management toggle is a settings button which launches yet another sliding pane that slides up from the bottom of the screen, covering both the open drawer, so here it covers there, and what is visible on the main content area. It will cover this as well. This overloading of popping and sliding panes, each moving in a different direction and affecting different layers of the UI design principle, limit the number of animated screen transitions. Unlike Google's Gmail app, the Google app for iOS slides the drawer open on top of the main content area. So instead of this pushing this to the right, it slides up on top rather than having the content area slide over to reveal the drawer underneath. This type of behavior usually seen on tablets when an index pane of content is open in portrait mode. So this is better. It's puzzling why Google didn't stick with the more appropriate idiom it was already using for its Gmail app. Actually, this is a bad idiom that it should be like this for mobile app. So the Google app breaks the drawer pattern by sliding it over the content area, more like an index pane instead of a sliding away the content area to reveal the drawer's content. Drawers controversy. Drawers using the hamburger menu have come under fire. The claim being that use of drawers hampers user engagement by hiding functionality. Certainly, there is some truth in these claims, hiding an entire nav hierarchy behind a single icon button does have its problem, but this can also be remedied via use of a text button like menu. So you can remedy that this drawer using menu and text, or in addition to the hamburger icon, having the initial use state of the drawer be open. So the initial drawer will be open, or initial use state or tab in that drawer. Making use of an initial help overlay could help as well. In some cases, the style of the hamburger might be the biggest problem. If the user doesn't register it as a control, then the failure is in visual communication. Benefits of drawer include a cleaner main interface with a more room for content and a means of making almost any function a swipe and possibly a scroll and tap away. For an app with a complex feature set, this can be a godsend. For apps where you expect users to be constantly using many functions, drawer may also work well. And apps that have many infrequently used but occasionally necessary functions might benefit from a drawer approach. On the other hand, apps that are only casually used may best use tabs or one of their variants for navigation, since users will not be using the app with enough frequency or dedication to recall the experience of features hidden within a drawer. So this for like a transient apps, you can use a tab instead. So tap to reveal and direct manipulation. One of the main differentiators of touchscreen mobile apps from desktop apps is the ability to use fingers to manipulate on-screen objects. Navigational constructs such as lists, carousels, and drawers allow users to navigate in a more immersive way, and the same principle can be applied to creating and editing a document. So one of the differentiator of this mobile apps to desktop is it allows you to touch it using this mobile handheld idioms like drawer list that allows for more immersive view, since it's mainly use a full screen unlike desktop. Tap to reveal controls. The iDraw app shown in figure 19.30 provides a good example of tap to reveal. Tap an object and the manipulation tools are revealed. So when you tap that, it allows you to show the tool palette at the left side. The iDraw app uses traditional desktop style drag handles that appears when an object is tapped. An additive selection mode allows successive taps to select additional object as a group. So there's actually an additive mode that you could click when you click an object that allows you to click another object. And it uses the same selection handle or drag handle in desktop. Similarly, streaming video app use the tap to reveal idiom for controls that normally are hidden during playback. So these are actually tap to reveal controls that is hidden when something or the documents are is not in manipulating state. So tapping anywhere on the video playback area of the YouTube app launches transport, volume, and other controls. So transport is usually for this video. YouTube makes its transport, volume, and other controls temporarily available as icons superimposed on the video area when it is stopped. After some time, it will vanish. So this design method helps eliminate clutter, but it must be discovered. Luckily, most mobile video apps use this idiom, and tapping the playback area isn't that much of a stretch. Direct manipulation controls. Some apps go to the next step of direct manipulation that touch-based screens permit, replacing cumbersome indirect manipulation idioms such as sliders with gestures on the object being edited. So direct manipulation control, some apps go to the next step of direct manipulation that touch-based screens permit, replacing cumbersome indirect manipulation such as sliders with gestures on the object being edited. So instead of the sliders, you have these gestures like tapping it using your left thumb and right thumb to change the rotation. So the best of these, such as Google Snap Speed Image Editor, provide a dynamic feedback hints that show roughly how the gestures will affect the object being edited. So here you have a tab bar, a bottom tab bar that allows you to see how it will look like when you use that gesture to the object you're editing. For instance, when you use this tilt shift effect, tapping the image displays a center adjustment point, as well as sets of double lines indicating the effect's angle and transition interval. See figure 19.32. The user can move the FX center point, swipe horizontally to widen or narrow the transition area. So you can swipe this. So instead of slider, you just need to swipe that horizontally to widen or narrow the transition area. So as you can see, we use a swipe instead of the slider. Also track by a thermometer like display below. And twist his or her thumb and forefinger on the screen to change the angle of the effect. So the user can move the FX center point, swipe horizontally to widen or narrow the transition area. Also track by thermometer like display below, and twist his or her thumb and forefinger. So you can twist the thumb and forefinger on the screen to change the angle. So that's what I'm saying, to change the angle or rotation. Snap Speed provides an innovative and highly immersive direct manipulation tools for editing images, eliminating the need for the traditional banks of knobs and sliders that such interface usually entail. So usually this editing has slides and knobs. It removes the clutter on the screen. The price of this approach is a steeper discovery curve. So the user already could immediately discover how to use it, but this disadvantage can be offset. This could be hard to discover these controls, but the disadvantage can be offset as Snap Speed does with one-time welcome or help screen for each tool. Although some discovery and learning are involved, it will quickly become second nature and provides tremendous immersive way of editing and correcting photos. Searching, sorting, and filtering. People use mobile apps to find something, whether it's a recent email, a song or video, something to buy, or something in the real world that's in their vicinity. But complex data entry is not easy or practical in the on-the-go world of mobile apps. Luckily, you have a variety of helpful ways to minimize this complex data entry. To minimize the effort in search, as well as contextual information on the mobile apps can provide. So here you have a context information that the mobile apps would provide. Here, popular or Netflix, you see that it's the popular TV dramas, etc. Implicit sorting versus explicit searching. We can utilize this browsing behavior to help preempt a user's need to build search queries. So we are predicting the user need based on their search queries. Based on their search, we're gonna show them the carousel that most likely fit on their profiles A smart app might keep track of the kinds of things the user has viewed, liked, or purchased. Then we could serve up those items more on the first option below, items that share similar properties. So that's actually how we show the content relevant to the news feed area. The content or the cards or the carousel that has the same properties, or the object the same properties, and are liked by people with tastes similar to those of the user. So there's a people such as like Facebook user, anonymous user that usually use the Facebook to view content for tech, would be shown similar properties object. So that's actually how you use this in the right way. Now Netflix has based its mobile app on this principle, see figure 19.14, providing a swim lane categories of TV shows and movies gleaned from the user's watching habits. Search is still available, but it is not the focus of the interface. So you're not searching, again, you're just using the swim lanes, but you're able to do better by connecting similar properties objects to relate to the user goals. Building search queries, of course, even with the best possible browse options, the users need to search for something specific is almost inevitable. The challenge in mobile app context is to allow sufficient expression of search terms, but with a minimum of data entry for the user. Here are a few of the most useful approach. Voice search. The three major mobile operating systems support in-app voice search, and you should certainly make this an option in your app. Voice search can certainly ease entry for simple searches in supported domains. However, we're a long way off from completely reliable general searches, so the need to enter and modify search terms manually still remains. Autocomplete, as the user types, displaying a list of popular options matching the entered letters can dramatically decrease keyboard time and user frustration. So it autocomplete that match displaying a list of popular options matching the entered letters that match the entered letters that the user search. So you collect the most popular search using that sequence of letter, and then autocomplete it. It will decrease keyboard time and user frustration. Tap ahead like this. You can tap anywhere on this available autocomplete option. So this is a refinement on top of autocomplete. Tap ahead allows user to take any autocompleted term option the app provide as the result of autosuggest. So load it into the search box and run a new complete query. So it load here on the search box. When you click this, it will load in this search box, and then it will run the query using that. So the auto suggestion here, a more sophisticated improvement on strict autocomplete. Auto suggest use of fuzzy matching techniques to provide a spell corrected, not just the popular, but spell corrected controlled vocabulary and synonym options in the option list, like the most recent type and then the most likely option that the user will type. Typically, auto-suggest option include a small set of strict autocomplete options at the top with the largest set of suggested results beneath. So there's a larger set when you click beneath that, that is provide more search option. Load it into the search box and run a new autocomplete query. This might be overkill for some searches, but it is certainly useful for web searches and in more technical domains where precision of search terms may be important. So this tap ahead may be overkill for just a simple app, but for web search, definitely worth it. The Google search app uses tap ahead as shown in figure 19.33. Google search app uses voice search and recent frequent search suggestion in left, autocomplete in right, and tap ahead both. So you can tap ahead here. Here you have autocomplete in right, recent and frequent search here in the left, and auto suggestion recent or frequent search suggestion in left ear Cooper. Recent or frequent searches. Humans are creatures of habit who typically search for the same things repeatedly. Any search functionality should remember past searches and present them as soon as the user taps the search box. Ideally, these results should be organized in order of most frequent and most recent. They also should support tap ahead so that they can be used to start a related search if desired, as Google Search App does. So as the auto-suggest, a more sophisticated improvement on strict autocomplete, auto-suggest use of fuzzy matching techniques to provide spell-corrected, controlled vocabulary and synonym option in its option list. It also uses synonym. Typically, auto-suggest option includes a small set of strict autocomplete options at the top with the largest set suggested results beneath. Categorize suggestion. So here, when you search for building an auto-suggest, an app that needs to search across several types of data, such as apps, App Store, can provide suggested option in each category. iOS Spotlight Search shown in 19.34 does this well. It provides instantaneous categorized suggestion with thumbnail images where appropriate, pulled from apps, contacts, music, videos, email, messages, calendar notes, reminders, and more. Figure 19.34 iOS Spotlight Search uses voice search, auto-suggest, and categorize suggestion. So it has a voice search as well, auto-suggest, and categorize suggestions, such as for apps and music, which is different type of data. Sorting and filtering. On mobile devices, sorting and filtering often amount to the same thing. This is because limits the number of search results user will want to scroll to a few screens at most. That's why there's a sorting and filtering. Thus, sorting effectively results in filtering out items at the bottom of the sort. Add to this fact that users don't always understand the difference between sorting and filtering. So filtering, you're choosing terms, but sorting, you're changing it from ascending to descending. So you should merge them into a single set of controls. So you should put them in the same set of drawers. Unfortunately, many high-profile apps don't get this quite right. So Amazon iPhone app, shown in figure 19.35, has a straightforward search that remembers recent searches. It also has a clear refine button in the nav bar of the search results. This is good so far. But the refined UI infuriatingly forces you to choose a department before you can even see a sort by option or any other filter option. So you need to choose a department here before you can see the feature. So this UI is good. You have a bottom bar and then the top bar, and then you can scroll in this one column, one, I don't know if it's a list or grid, but for this filter, to get into the filter by choosing a department first is overkill and takes before you can even see a sort by option or any other filter option, and takes you back to the results page before you can choose it. The consequences is that users may not even realize that additional sort and filter options are available. So Amazon's iPhone app fails users by allowing them to choose only one refinement option at a time, and by hiding most refinement options until a department filter is selected. Undoubtedly, this is due to a database integration issue on Amazon's back end, but it's Amazon customers who suffer. The Open Table app search option of the interface has an appropriate filters for a restaurant reservation app built in. Time and location, as well as the expected keyword search for restaurants. Both time and location are also sensibly populated, and search refinement options are clear and simple, with the most important at the top and more fuzzy criteria collapse at the bottom. So it has the appropriate filter for its context, time and location, as well as the expected keyword search for restaurants. So here it provides a find a restaurant keyword, kind of like in the search box, which is appropriate for this context. Both time and location are also sensibly pre-populated. So it's sensibly there's a default based that detects based on the location, and it has this keyboard that pops up when you type in the find restaurant. You have a stop bar, and then you have this. I think it's drawer, something like that. Yeah, this filter is I think this is drawer, which is combination of search, filter, and sorting controls. And search refinement options are clear and simple as well, with the most important at the top and more fuzzy criteria collapse at the bottom. So here you have the search bar. When you click this, it pops up this. Yeah, I think that's drawer with the top bar, navigation bar at the top. When you click the search, here you have a bottom bar that collapse when you click the search. That allows you to choose the fuzzy criteria based on the most important, such as distance, um, alphabetical rating, so price, so until the bottom. So the only Fox Pass open to table mix is placing its filter control behind the somewhat obscure icon in the lower right of the screen, where people are almost sure to miss it. So here, open table up does a great job searching left and filtering right, except for the filter control placement center. It's almost invisible in the lower right of the screen, especially since it disappears entirely when you scroll down. So when you scroll this down, this it disappears, though it does come back when you scroll up. Yelp takes no nonsense approach to refinement in its up with a prominent refine button to the left of the search box on the result screen. See figure 19.37. Tapping the button opens a full screen dialog that mixes filter and sort controls, each of which is clearly labeled and appropriately prioritized from top to bottom. So the refinement that use the search to filter and sort are are on the left on the search bar, so you can immediately see it. So tapping the button opens a full screen dialog. So it's actually, these are dialog, it's not a drawer. That mixes filter and sort controls. So here you can filter and then sort the result or the content, each of which is clearly visible, labeled, and appropriately prioritized from top to bottom. Open now, or most popular, distance, sort by general feature. Yelp and Amazon both get another detail right. Filtered results are indicated by another filter bar. So here you see full bar takes reservation anchored to the top of the results view. So here's the result view, and there's the title bar that shows you like the click path. This bar contains a terse textual summary of all current filters on the results. So all the filters that you put are actually in here. A nice addition to this interface would be the ability to swipe horizontally To see a full list of active filters in this navigation bar, you can swipe this. The list is truncated in the Yelp interface. Another advantage would be the ability to toggle the filter on and off. Yeah, so the toggle button could be put here to turn off the filter without needing to return to the refine screen. So here is the refine screen filter. So the Yelp app gets searching and filtering right. A clearly labeled filter button at the top left of the results screen left, and a full screen modal pop up appropriately mixes filter and sort criteria. So that's actually full screen model pop up. The results screen also show a narrow filter bar identifying which filters have been set. So this full screen actually, the result screen are also show narrow filter bar, identifying which filters have been set. Here is the filter bar. So welcome and new screens, well, mainly mobile interfaces are quite easy to learn. Some forces unique to mobile design act in opposition to ease of learnability. Limited screen real estate effectively limits the amount of textual labeling or instructive text that can be on the screen at any time. Multi-touch interfaces center on the use of gesture to accomplish actions, which have no visible affordance until finger touch or move across the screen. So since it uses gestures, that's one of its weakness, since it's also one of its strengths that provides immersive control or experience. Unlike mouse-driven desktop interfaces, there's no hover state to afford tooltips and other contextual hints. While some other alternatives exist, the simplest and most effective way to help users learn a mobile interface is through Welcome and Help screen. Welcome and Help interface are most often two sides of the same coins in mobile apps. Both provide guidance on what the important activities are in the app and how to perform them. So it shows the most important activities or functions that you can do. Help in a mobile context provide much the same and often identical information, but on demand when the user requests it. Most mobile apps aren't complex enough to require separate welcome and help screens for different tabs or other views in the drawer, but this might make sense for a more sophisticated authoring tools with many controls, options, and actions. This section describes several popular welcome and help idioms that help users learn an app, primary gestures and interactions. Guided tours. Guided tours usually consist of carousel of cards. So it's a carousel of cards that you can swipe and you can also skip right there on that page, each of which contains text and images or video. It could be in different a text, image, or video format that describe the use of a particular function or set of related app functions. Guided tours are employed at first use and after a major release to highlight new function, and secondarily as help. Many apps that allow user to relaunch the tour from an in-app settings like dialogue or less frequently from a help button or menu placed in a top or bottom navigation bar. It also allows the apps to relaunch this guided tours from an in-app setting dialog or less frequently from a help button or menu placed in a tool, a top or bottom navigation bar. So there are navigation bar we discussed, but it could be in the settings dialog. So usually it is hidden since it is by request, or it's not that as usual as in a welcome screen. So guided tour should allow users to exit the tour from any card or screen. Design principle: use guided tours to orient first-time users. Overlay Overlays are another simple way to help users get started. An overlay covers the entire screen with a semi-transparent layer on which instructions, often rendered to look hand-drawn. So here is like the common, I think the common welcome interface today. Guided tours is the overlay, which is like a transparent that just cover the main content area and employing arrows to indicate gestures or highlight controls. So it uses arrows to indicate the controls. Tapping anywhere on the screen dismisses the overlay. This is sometimes accomplished with a close box as with guided tours. Overlays can be activated again from a help button or settings dialog. Design principle: use overlays to explicate gestures. Tooltip overlays. Tooltip overlays are an overlay variation that attempts to provide a tooltip-like display of all primary functions on a single overlay screen and is often used in the context of more complex authoring apps. As such, this idiom is best not used as a welcome screen but rather as a help screen. Multitask gestures. Gestures are the heart of mobile experience, although the kind of experience afforded by gesture is quite rich and immersive. The actual number of core gestures is fairly small, and this is for best. Keeping gestures simple and straightforward makes them easy to discover and learn. This section describes the primary use of the most frequently used multi-touch gestures. Multi-touch gestures: tap to select, activate, or toggle. The tap is used to select objects and toggle the activation state of controls. So the controls has a different state in its object, and tapping it or that object activate it when it's tapped. Tap item should get an appropriate selection highlight or reach mode less feedback or activation or deactivation state or animations. Tap and hold. Tap and hold is a gestural idiom that is falling out of favor because this gesture isn't very discoverable and few users are familiar with it. Therefore, this gesture isn't recommended. It typically used to open a contextual pop-up menu on an object similar to the desktop right-click idiom. Drag to scroll. Drag to scroll can work horizontally or vertically. Vertical dragging can be used to scroll list. So if you drag it vertically, you can scroll lists or grids. In conjunction with a drag handle, it can also reorder objects in a list. So a drag handle could also reorder that in a list. Dragging or so it's not a tap and hold, but it's just a handle that you use to drag a different on the different part of the screen, because tap and hold is different, in which you just tap it in one area of the screen. Dragging downward on the list will initiate a refresh when the list has been already scrolled up. So it will call the list or initiate a list when the list has been already scrolled up. So that's actually how it works in mobile app. A drag upward, on the other hand, will initiate an incremental addition of items. So it actually incremental addition items in the list or grid after the last displayed item in the list. So after the last displayed item, it is programmed that way so that you can see that in order after the previous displayed item. We can also map this vertical dragging to the top and bottom drawers by some mobile OS apps. So you can also map this vertical dragging to see the top and bottom drawer, just like what we see in the top and bottom navigation bar. On the other hand, we can map the horizontal dragging that can scroll the app carousel or swim lane content or open a left hand or right hand drawer. So we're actually just mapping this button. We're not really programming this from scratch. We're just mapping this on the OS. So these inputs are just being mapped on our objects, whether it's carousel, list, or grids on the back end. So drag to move. Dragging can also be used to move or copy an object from one list to another and from one pane to another. It can also move an object within a canvas or grid. Drag to control. Dragging can also be used to control sliders. Instead of moving, you're controlling another control. So instead of moving an object, you're moving the sliders. Switches and knobs we see in instrument application. It can also be used to drag and drop a brush from a tool palette and used it on the content area in the application. So you can drag and drop it, a brush from a tool palette from the left side and use it on the content area to control. Swipe up or down. Swiping is synonymous with dragging up. Swiping a list or grid upward causes it to continue scrolling for a while with simulated momentum. Swiping down usually is synonymous with dragging down. Swiping a list or grid downward causes it to continue scrolling for a while simulated momentum. So there's actually a simulated momentum that limits that swiping. Swipe left. Swipe left is usually synonymous with dragging left. Swiping a carousel or swim lane to the left causes it to continue scrolling for a while with simulated momentum. Swiping left can also open a right-hand drawer or close a left-hand drawer. Apple Summary Browser uses swipe left to navigate like the forward button. Google's Chrome browser uses swipe left to delete browser tabs when in tab edit mode. Swipe right. Swipe right usually is synonymous with dragging right. Swiping a carousel or swim lane to the right causes it to continue scrolling for a while with simulated momentum. Swiping right also can open a left-hand drawer or close a right-hand drawer. So we can map a swipe left or swipe right in opening and closing a drawer. Apple Safari browser uses a swipe right to navigate, like the back button. Google's Chrome browser uses a swipe right to delete browser tabs when in tab edit mode. Pinch in or out. The pinch in gesture is used to shrink. Oh my god. The pinch in gesture is used to shrink or zoom out an objects physically, such as on map view, or you can perform a semantic zoom. Zoom out or up one level in the hierarchy in a set of physically or conceptually nested structure. So the one zoom is actually in physically or conceptually nested structure or tree-like structure. The pinch out gesture is used to expand or zoom in on objects physically, such as on a map view. Or you can perform a semantic zoom, zooming in or down one level in the hierarchy in a set of physically or conceptually nested structures. Rotate. Rotate is a gesture employing the thumb of finger twisted clockwise or counterclockwise together on the touchscreen surface. This gesture can be used to actuate knob controls, but knobs probably should also support a horizontal or vertical drag action. So rotate is for knobs, right, for volume, but it should also support knob should also support horizontal and vertical drag action that starts on the knob as an alternative and more discoverable gesture. It can also be used to rotate objects, like the selection of pixels in an image editing app. This gesture is somewhat awkward to carry out given the anatomy of human wrist. 53's Ink iOS app paper uses this gesture to control undo or redo. So sometimes it can be used for undo and redo, but it's hard for the wrist, so should avoid this. Although this is a novel approach, it seems inferior to the more standard undo or redo arrow icons from a usability standpoint. Multi-finger swipes. The various mobile OS use various multi-finger swipe gestures. For example, iOS supports an option that permits four-finger left or right swipe to switch between running apps. On the whole, multi-finger gestures are not very discoverable, and when used in apps, may interfere with OS level gestures. Inter-app integration. Modern smartphones with their standalone app approach have created marvelous ecosystem in which user can easily add amazing functionality to their devices through an app store. This approach does have one Achilles heel. Standalone apps tend not to foster the user integration of functionality and data between them. Most of the standalone actually not utilize the data and the functionality of objects between them. For example, the iPhone has an phone app, a contacts app, a calendar app, a messaging app, a memo app, and reminders app. However, these apps are almost completely standalone and do not communicate with each other except in most rudimentary ways. The iPhone and other modern smartphones currently do a reasonable job of integrating the phone and contacts app. When call arrives, you can see the full name from the address book, and by tapping a button in the address book, you can dial it. However, this integration could be taken step further. Clicking a name in the address book could give you a reverse chronological list or set of list of all documents that are associated with that person. Appointments, emails, phone calls from the log, memos including the caller's name, website associated with the person, the last time you communicated, the location, etc. Similarly, when an incoming call arrives, the phone could check your location, such as cinema, or see if you are currently in a meeting that's on your calendar. So the phone detects it so that it won't disturb you. It could automatically silence the ringer and perhaps even say that I'm busy and will call you back later text message to the person calling you. Unless the call is from someone on your VIP list of callers. So it could also automatically silence it and then send an IBC automatic message unless the caller is emergency contact. It's unfortunate that phone manufacturers haven't yet applied this kind of integration to the core suite of phone apps. However, some clever apps like IFTT, if this then that, do allow apps that participate to their service to be wired together with customizable rules that allow for some level of app integration. Figure 19.38. So the IFTT app lets user wire together apps by allowing them to specify output and input triggers, effectively allowing simple app integration. For music production, Audiobus is an integration-oriented iOS app that allows other compatible iOS audio application to route multiple input audio streams to multiple audio outputs. So this effectively allows an entire virtual recording studio to exist within an iPhone or iPad. The Audio Bus app allows user to chain together the audio stream from compatible running apps. Doing so supports input, output, and effects, allowing an entire virtual recording studio to exist within an iPad. Other devices, unlike software running on a desktop computer or high-resolution mobile device, interaction designed for device embedded interfaces requires special attention to creating an experience that coexists with the noise and activity of the real world happening around the product, combined with the typically limited screen and computational resources needed to render it. General design principles: don't think of your product as computer. Your users will approach your product with specific expectations about what the product can do. If it's an appliance or familiar handheld device, or with every few expectations, if you're designing a public kiosk, the last thing you want to do is bring all the baggage, the idioms, and terminology of the desktop computer world with you to a simple device like camera or microwave oven. Similarly, users of scientific and other technical equipment expect quick and direct access to data and controls within their domains without having to wade through a computer operating system or file system to find what they need. Designers, especially those who have designed for desktop platforms, can easily forget that even though they are designing software, they are not always designing it for computers in the usual sense. Devices with large color screen, lots of power and memory, full-size keyboards, and mouse pointing devices. And most importantly, these products are used in much different contexts than desktop computers. Idioms that have become accepted on a PC are inappropriate on an embedded device. Cancel is not an appropriate label for a button to turn off an oven, and requiring people to enter a settings mode to change the temperature on a thermostat is preposterous. Much better is to see it as what it is and see how digital tech can be applied to enhance the experience for its users. Integrate your hardware and software design. Embedded system often benefit from custom hardware. Desktop computers are meant to be all-purpose due to cost, power, and form factor constraint. Hardware-based navigation and input control must often take the place of on-screen equivalents. Many of the best, most innovative digital devices of the last several decades, such as the TiVo and original iPad, were designed from such a holistic perspective. Hardware and software combine seamlessly to create a compelling and effective experience for users as shown in figure 19.40. This doesn't occur often enough in the standard development process. Hardware engineering teams regularly hand off completed mechanical and industrial designs to the software teams, who must then accommodate them, regardless of what is best from the user perspective. So, a Copper design for a smart desktop phone exhibiting strong integration of hardware and software controls. User can easily adjust volume or speakerphone, dial new numbers, and control playback of voicemail messages with hardware controls. They also can manage known contacts or numbers, incoming calls, call logs, voicemail, and conferencing feature using the touchscreen and thumb wheel. Rather than attempting to load too much functionality into the system, the design focuses on making the most frequent and important phone features much easier to use. Note the finger size regions devoted to touchable areas on the screen and the use of text hints to reinforce interactions. Let context drive the design. Another distinct difference between embedded systems and desktop applications is the importance of environmental context. Although desktop applications sometimes introduce contextual concerns, designers generally can assume that most software running on the desktop will be used on a computer that is stationary and located in a relatively quiet and private location. Although this is becoming less true as laptops gain both wireless capabilities and the power of desktop systems, it remains true that users will, by necessity of form factor, be stationary and out of the hub even when using laptops. Even embedded systems that are mostly stationary and secluded, like household appliances, have strong contextual element. For example, hosts juggling plates of hot food at dinner parties distracted, not in a focused state of mind, to navigate a cumbersome set of controls for a smart oven. Navigation system built into a car's dashboard cannot safely use soft keys that change their meaning in different contexts because the driver would be forced to take her eyes off the road to read each function label. Similarly, a technician on a manufacturing floor should not be required to focus on difficult to decipher equipment controls because that kind of distraction could be life-threatening in some circumstances. Thus, the design of embedded system must match very close the context of use. For handhelds, this context concern how and where the device is physically handled. Use modes judiciously if at all. Desktop computer applications are often rich in modes. The software can be in many different states in which input and other controls are mapped to different behaviors. Tool palettes such as those in Photoshop are a good example. When you choose a tool, mouse and keyboard actions are mapped to a set of functions defined by that particular tool. When you choose a new tool, the behavior resulting from similar input changes. Unfortunately, users are easily confounded by model behavior, and because devices typically have smaller displays and limited input mechanism, it is very difficult to convey what the mode the product is in, and significant navigational work is often required to change modes. Take for example pre-smartphone mobile telephones. They often require navigation of seemingly countless modes organized into hierarchical menus. Most of these old-school mobile phones users only master the dialing and address book functionality, but quickly got lost when they tried to access other functions. Even as important function such as silencing the ringer was often a daunting task. Ideally, mode switches should result naturally from situational changes in context. For example, it makes sense for a smartphone to shift into a telephone mode when an incoming call is received, and to shift back to its previous mode when the call is terminated. If phones are truly necessary, they should be clearly accessible in the interface, and the exit path should also be immediately clear. Limit the scope. Users will be better served by the devices that enable them to do a limited set of tasks more effectively than by the devices that attempt to address too many disparate tasks in one place. Many devices like smartphones is an extension or satellite of the desktop, providing key information and functions in contexts where the desktop system is unavailable. Scenarios can help you determine what functions are truly useful for such satellite systems. Balanced navigation and display density. Whether the underlying reasons are hardware cost, form factor, portability, or power requirements, designers must make the best use of the display technology available while meeting users' information needs. Such limitation in display real estate almost always in a trade-off between clarity of information displayed and complexity of navigation. By appropriately limiting the scope of functions, you can ameliorate this situation somewhat, but the tension between display and navigation almost always exists to some degree. Certainly, it's best to completely flatten the information hierarchy if possible. Determine the most important information to get across and make it the most prominent. Then look to see what ancillary information can still fit on the screen. Minimize input complexity. All embedded systems have simplified inputs, not general purpose keyboards or desktop style pointing device. This means that any input to the system, especially text input, is awkward, slow, and difficult for users. Even the most sophisticated of these input systems, such as touchscreen, voice recognition, handwriting recognition, and thumb boards, are cumbersome in comparison to full-size keyboards and mice. Touchscreen should also avoid idioms that involve dragging. Single-tap idioms are easier to control and more obvious when give proper affordance to novice users such as transient application. Designing for single-purpose handheld device. When designing for a single-purpose handheld device, think about how the device will be held and carried. Physical models are essential to understanding how a device will be manipulated. The modes should at least reflect the device size, shape, and articulation, flip covers, and so on. They are more effective when weight is also taken into account. These models should be employed by designers in context and key path scenarios to evaluate proposed form factors. Labels on buttons have very different contextual needs depending on where and when they will be used. It's okay for a device that is intended primarily for one-handed use to support some advanced functions that require two-handed use, as long as they are needed infrequently. Avoid use of pluralized and pop-up windows. Floating windows typically have no place on small, low-resolution screen. In this regard, interfaces should resemble sovereign posture application using the full screen real estate. Modest dialogue should always be avoided. Modal dialogues and errors should, whenever possible, be replaced using techniques rich modeless feedback. Designing for kiosk user in comparison with sovereign desktop application users are at best infrequent users of kiosks and most typically use any given kiosk only once. Furthermore, kiosk users will have either specific goal in mind when approaching a kiosk or no readily definable goal at all. Kiosk users typically don't have access to keywords or pointing devices, and often they would be unable to use either effectively even if they did. Transaction versus exploration. Transactional kiosks includes bank machines, ATMs, and ticketing machines, such as those used in airport, train, bus depots, and some movie theaters. Even gasoline pumps and vending machines can be considered a simple type of transactional kiosk. Users of transactional kiosks have specific goals in mind: to get cash, a ticket, a Tootsie Roll, or specific piece of information. These users have no interest in anything but accomplishing their goals as quickly and painlessly as possible. Explorational kiosks are somewhat different from transactional kiosks in that users typically have open-ended expectation when approaching them. They may be curious or want to be entertained or enlightened, but they may not have any specific end goals in mind. For exploration kiosks, the act of exploring must engage the user. Therefore, not only must the kiosk interface be clear and easy to navigate, but it also must be aesthetically pleasing and visually and possibly audibly exciting to users. So the Getty Guide system of informational kiosks at the J. Getty Center in Villa in Los Angeles, designed by Coover in collaboration with Getty and triple quote interaction in public environment. Transactional kiosks use a rule require no special enticements to attract users. However, they do need to be placed in an optimal location to be obviously visible and to handle the flow of user traffic they will generate. Use wayfinding and sign systems in conjunction with this kiosk for maximum effectiveness. Some transactional kiosks, especially ATMs, need to take into account security issues. If their location seems insecure, user will avoid them or consider them risky. Architectural planning for transactional kiosks should occur at the same time as the interaction and industrial design planning. As with transactional kiosks, place explorational kiosks carefully and use wayfinding system in conjunction with them. They must not obstruct any main attractions and yet must be close enough to the attraction to be perceived as connected to them. There must be adequate room for people to gather because exploration kiosks are more likely to be used by groups such as families. A particular challenge lies in choosing the right number of kiosks to install at a location. Companies employing transactional kiosks often engage in user flow research at a site to determine optimum numbers. People don't linger long at transactional kiosks and they are usually more willing to wait in line because they have definite end goal in mind. Because potential users have few expectations of the content of an explorational kiosk, it becomes difficult for them to justify waiting in line to use one. It is safe to assume that most people will approach an exploration kiosk only when it is vacant. Managing input, most kiosks use either touchscreen or hardware buttons and keypads that are mapped to objects and functions on the screen. In the case of touchscreen, the same principle apply as other touchscreen interfaces. Make sure that your click targets are large enough. Touchable objects should be large enough to be manipulated with the finger, high contrast, colorful, and well separated on the screen to avoid accidental selection. A 20mm click target is a typical minimum if users will be close to the screen and not in a hurry. This size should be increased or used at arm's length or when in a rush. A good low-tech trick to make sure that your click target are large enough is to print the screen at actual size. Ink your fingertip tip with an ink pad and run through your scenarios at a realistic speed. If your fingertips overlap the edges of your click targets, you probably should increase their size. It's messy but incontrovertible. Use a soft keyboard input sparingly. It may be tempting to use an on-screen keyboard to enter data on touch-screen kiosk. However, this input mechanism should be used only to enter very small amount of text. Not only is it awkward for the user, but it also typically results in a thick coating of fingertips on the display. Avoid drag and drop. This gesture can be difficult for user to master on touchscreen, making it inappropriate for kiosk. User who will never spend the necessary time to master the demanding interaction idioms. Scrolling of any kind should also be avoided on kiosks except when absolute necessary. Touchscreens, as in handheld systems, the key concern is that this mapping remain consistent with similar function mapped to the same buttons from screen to screen. This button also should be placed so far from the screen or arranged spatially so that mapping becomes unclear. Uh, in general, if a touchscreen is feasible, you should strongly consider it in a favor of map hardware buttons. So if a touch display is feasible, you should choose that instead of a hardware button. Designing for 10-foot interfaces. Most remote controls use inexpensive infrared light to communicate, so unless the remote control uses more expensive radio frequency technology, this also means that the user needs to point the remote at the TV and set top boxes. All of this makes for challenges and limitation in designing effective information display controls for system navigation and operation. So it's hard to put the display control we talked about in the previous video and system navigation and operation. It turns out that lists, grids, carousels, and swim lanes all map reasonably well to 10-foot interfaces because D-pad navigation consists of up, down, and left-right movements. This is good news for designers of services like Netflix, which live both on mobile devices and set-top boxes. Such interfaces can often adapted across this platform with only minor adjustment. As discussed in Chapter 17, Microsoft Metro Design Language successfully spanned desktop, mobile, and set-top platforms. Use screen layout and visual design that can be easily read from across the room. Even if you think you can rely on high-definition television screen resolution, your users will not be close to the TV as they would be to, say, a computer monitor. This means that the text and other navigable content needs to be displayed in a larger size, which in turn this dictates how screen of information are organized. Keep screen navigation simple. People don't think about their TV like they do a computer, and the navigation mechanism provided by remotes are limited. Therefore, the best approach is one that can be mapped easily to a 5-way up, down, left, right, and select control. So you need to minimize the scope and the input as well. There may be room to innovate with scroll wheels and other input mechanisms for content navigation, such as the properties in the content or object itself. In addition, visual wayfinding techniques are important for ensuring ease of use. So you use visual wayfinding the same as in the kiosk as well. These include color coding screens by functional area. So that's a wayfinding actually. Color coding schemes, a function, related function, and providing visual or textual hints about what navigational and command options are available on its screen. So it's like a rich mode visual feedback. TiVo does a particular good job of this. Keep remote controls as simple as possible. Many users find complex remote controls daunting, and most functions available from typical home entertainment remote remains little used, especially when remote controls take on universal functionality. The tendency is to cram them with buttons. It's not unusual to see 40, 50, or even 60 buttons on a universal remote. One way to mitigate this is to add a display to the remote. This can allow controls to appear in context, provide additional information to the user, so fewer buttons are needed at any one time. These controls can be accessed via a touchscreen or via soft-label physical buttons that lie adjacent to the TV screen. Each of these approach has drawbacks. The vast majority of touchscreen do not provide tactile feedback, so the user is forced to look away from his or her TV to actuate a touchscreen control. Soft-labeled buttons address this problem but add back more button to the remote's surface. So soft-labeled buttons such as the one in the button surface solve the tactile feedback, but it adds more buttons, so you need to balance. The addition of display on your remote may also tempt you to allow navigation to multiple pages of content or control on the display. This may be warranted sometimes, but any design choice that divides the user attention between two displays, the TV and remote, runs the risk of creating user confusion and annoyance. So if the user switch the tactile feedback and the remote, it will provide annoyance. Focus on user goal and activities, not on product functions. Remote controls like Logitech Harmony take a different approach, organizing around user activities such as watch a movie and building a detailed understanding of the user entertainment setup through a very usable setup wizard. While this is much more complex to develop, it is clear win for user if implemented well. Most home entertainment systems require user to understand the topology and system state to use it effectively. Designing for automotive interfaces, such systems require significant design effort and usability validation to avoid such issues. Add to the risk factor the spatial limitations of the automobile dashboard, center console, and steering wheel, and you have a very particular challenge. Minimize the amount of time hands are off the wheel. Commonly used navigation controls such as play or pause, mute, and skip should be available on the steering wheel, driver use, as well as on the center console, passenger use. And force consistent layout from screen to screen. If you maintain a consistent layout, the driver will be able to keep his bearing between context shifts. Use direct control mappings when possible. Controls with labels on them are better than soft label controls. Touchscreen buttons with tactile feedback are also preferable to soft labels with adjacent hard buttons, because again this requires fewer cognitive cycles from the driver operating the system to make mapping. Choose the input mechanism carefully. It's much easier for the driver to select content from knobs than from a set of buttons. There are fewer controls to clutter the interface, knobs put root, and therefore easier to reach. And when properly designed, they afford both rough and fine controls in an elegant and intuitive way. Differentiate the physical design of different controls clearly so they can be managed as much as possible by touch. Use very strong contrast in the visual design of displays and a very shallow visual hierarchy to enable quick glances for information. Keep mode or context switching simple and predictable. With its reviled iDrive system, BMW mapped most of the car's entertainment, climate control, and navigation into a single control. That was a combination knob or joystick. The idea was to make things simple, but by overloading the controls so extensively, BMW created a danger for user by requiring them to navigate an interface in order to switch contexts and modes. Modes such as switching from CD to FM or from climate control to navigation should be directly accessible with a single touch or button press. Audible confirmations of command help reduce the need for the driver to take his eyes off the road. However, you should ensure that his feedback is itself not too loud or distracting. For in-car navigation system, verbal feedback highlighting the driving direction can be helpful. This is true as long as the verbal help, such as turning instruction and street name, is delivered early enough for the driver to react to in time. It is unclear, however, verbalizing a command, especially if it needs to be repeated or corrected, for is any less cognitively demanding than pressing a button. While this kind of feature makes for great marketing, we think the jury is still out on whether it makes for a better or safer user experience in the automobile. Designing for audible interfaces, navigation is the most critical issue because it's easy to get lost in a tree of functionality with no means of visualizing where you are in the hierarchy. Almost all voice interfaces are based on a tree, even if the options are hidden behind voice recognition, which introduce a whole other set of idioms. Organize and name functions according to user mental models. This is important in any design, but is doubly important when functions are described only verbally and only in the context of the current function. Be sure to examine context scenarios to determine what the most important functions are and make them most easily reachable. This means listing the most common options first. Always signpost the currently available functions. After every user action, the system should restate the currently available activities and how to invoke them. Always provide a way to go back one step and to return to the top level and after every action. The system should tell the user how to go back one step in the function structure, usually up one node in the tree, and how to get to the top level of the function tree. Gives the user enough time to respond. System usually require verbal or telephone keypad entry of information. Testing should be done to determine an appropriate amount of time to wait. Keep in mind that phone keypads can be awkward and very slow for entering textual information. Perfect. So we're done. Next video, we will discuss designing for web. So here we have designing for web, page-based interaction, navigation, and wayfinding, as well primary navigation, like primary drawer, secondary navigation, and beyond. And then we have content navigation, searching. We also have scrolling here, the header and footer, paging versus infinite scrolling, and then the mobile web, and the future. And for rethinking data storage, we have a lot as well here. Rethinking data entry, storage, and retrieval. For rethinking data entry, data integrity versus data immunity, handling missing data entry and fudgeability, auditing versus editing. Rethinking data storage, the problems with data storage, saving changes, closing documents without saving, save as. We also have archiving, fixing data storage, a unified file model, automatic save, creating a copy, naming and renaming, placing and positioning in the file system, specifying the file type. We also have reversing changes, discarding all changes, creating a version, a new file menu, a new name for the file menu, communicating status, and time for a change. Rethinking data retrieval, storage versus retrieval in the physical world, index retrieval in the digital world, digital retrieval methods, attribute-based retrieval system, relational database versus digital soup, organizing the unorganizable problems with database, the attributes-based alternative, constrained natural language output. So that's it, guys. Thank you for watching. See you in the next video. Peace.